We will begin by demonstrating how to run the 28000 GUI software and configure the system interface to the PC. The program can be run from the Start menu or from a desktop icon. When the program is run, the 28000 system build panel opens and displays the system configuration. The 28000 build panel allows for up to 8 28000 mainframes to be controlled from a single GUI program. The communication interface to the 28000 mainframes is set up in this panel. The 28000 GUI software will dialogue with the user to report communication timeout conditions and to allow the communication interface to be configured to a serial or Ethernet connection. The 28000 system interfaces to a host PC through a direct connection or network using the 28000 BIF control card. The serial or Ethernet interface cables are connected to the 28000 BIF control card. The serial option provides a communication link using RS-232 format. The Ethernet interface can be configured to provide a link to the mainframe using a local or network connection with static or dynamic IP addressing. The GUI software prompts to define the connection method and allows the user to define the connection method. For the serial interface, the 28000 GUI software will automatically read the available COM ports on the PC and display them with a default baud rate of 57600. The baud rate and communications port settings can be configured in the build panel for each chassis that is connected. For the Ethernet interface, the TCP/IP address of the GUI software will default to the default address of the 28000 BIF card, 169.254.1.221. This address, along with the default Ethernet subnet mask of 255.255.0.0, can be modified per unit. Once the 28000 program connects to the mainframe, it will read the inventory of signal conditioning cards in the system as well as the mainframe control card. Once the GUI software takes an inventory of the cards installed in each mainframe, the GUI software will program the signal conditioning cards to either the last saved configuration settings, if there was a previous configuration, or will program the signal conditioning channels to the default settings. The 28000 GUI software can be configured with the system's hardware settings and can be saved and recalled. The 28000 GUI's main panel provides system-level controls that provide an easy way to identify and track channels in the system. When the 28000 GUI creates a system configuration from the inventory of cards it finds in the mainframes, it assigns a unique channel number and system location number to the channel. This channel number is shown on the far left of the GUI channel control ribbon. Next to this channel number is the channel's physical location, which consists of the mainframe location, slot in the mainframe, channel location on the card. This is referred to as the triplet and is a 3-digit number. First digits indicate mainframe, second digits indicate slot location in the mainframe, and third digit indicates card channel. The 28000 GUI also provides a feature that allows the user to name each channel. This capability is provided through the 28000 GUI's Configure Assign Labels menus and allows unique names to be given to each channel in the system. The 28000 system also offers an integrated health monitor. The System Health Status field provides an indication of system health status for each system. It measures the system power supply voltages and fan circuits in the 28000 mainframes. Indicator lights in the main GUI panel indicate that the 28000 power supplies, cooling fans, and system temperatures are functioning properly and are within acceptable limits. The 28000 Health Monitor panel provides additional information about the status of the system by displaying the temperature and voltage measurements inside each system. These parameters are automatically scanned and reported into this panel. If the system finds a fault in the system, the indicator LEDs will be turned on and an audible alarm will sound. The 28000 system provides a system monitor function that allows the output of any channel in the system to be monitored through two buffered outputs. These buffered outputs are a scope monitor B and C on the front of the 28000 control card, and a rear panel output on the rear of the mainframe that can be routed to a DVM. This feature provides a convenient way to monitor signals at the output of the signal conditioner prior to data recording and digitizing without disconnecting output cables. The monitor outputs are provided on a drop-down panel in the GUI screen and are labeled with the channel numbers, names, and triplet addresses that are assigned. The 28000 GUI provides programming modes that allow for full access to channel controls during setup and limits accessibility during test. This feature is called the Setup Operate Mode function. The 28000 GUI provides controls that allow access for some or all channel controls during setup and limits controls during test to prevent changes from accidentally being made to pre-test settings. The accessibility settings are controlled using the Setup Exclude control panel that is accessed by right-clicking the mouse onto a channel control panel. The Define Operate panel allows the user to select which controls are limited during the operate mode. The 28000 GUI provides access to the 28000 system manuals and to 28000 signal conditioning card manuals through the GUI interface. This help feature provides an easy access to system reference manuals. The Help menu item on the GUI's top control ribbon opens links to the 28000 system manual and the general topics sections. These topics include basic operating instructions for the GUI software and basic information for connection to cards. The Help menu dropdown also includes links to manuals for specific card models that are found in the inventory of cards in the system. In addition, the Help menu includes software release information and link to PFI website and are included in the drop-down menu. The 28000 GUI's main panel also displays all of the channel level controls for the signal conditioning cards in the system. The 28000 GUI provides a control interface and display capability for the system hardware at the card and channel level. 28000 GUI card control panels are grouped by unique card model. Each specific model of channels found in the system are displayed in groups. The main control panel for a group of channels is shown by a dark blue control ribbon. This is called the Control Group panel. The control ribbon allows for channel settings to be set globally over a specific channel type in the system. Settings changed in the group panel will be imposed onto all channels in the group. Different group control panels will be displayed for each set of unique card models found in the system. The member channels of a control group can be viewed and controlled independently. This is done by expanding the group control by pressing the Display Members field. The member channels of a group are displayed on individual ribbons under the main control ribbon. Individual channel controls are displayed and can be changed on the channel control ribbons. For each individual channel control ribbon, a unique channel name, system location, which is the triplet, is displayed on the far left of the panel. The 28000 GUI allows access and control of the signal conditioning card's test modes. These are diagnostic operating modes that the signal conditioning channels can be put into for the purposes of injecting test signals to verify channel settings and function. These test modes can also be used to verify sensor setups and for troubleshooting purposes. Some of the test modes are general to all card models, while other test modes are specific to the functions of the specific signal conditioning cards. The test modes can be set globally in the group control panel or controlled individually in the channel control ribbons. The 28000 GUI also features fault and overload indicators for the signal conditioning channels. These are grouped on the panel as a series of indicator lights. These indicator lights are displayed for each channel as well as in the group panel. A fault or overload condition will be displayed on the individual channel where the fault is occurring as well as in the group display panel. This allows for a quick look to see if any channel in the group has a fault condition as well as indicating the individual channel fault and overloads for the system channels. These indicator lights include a short and open loop resistance condition indicator and also an indicator of measured loop resistance faults. The loop resistance faults can be set by the user to have user-specified thresholds for open and short. The indicator lights also indicate excitation current limit and regulation faults, excitation supply thermal shutdown indicators, and amplifier input overload indications that will alert the user if the voltage in the amplifier is out of range of the compliance of the amplifier. The indicator lights can be set to operate as real-time fault indicators that change and update in actual time, or can be set to a latch mode to allow fault conditions to be captured and latched on the display screen until reset by the user. This real-time latching fault and overload mode is set in the 28,000 options panel in the GUI. The 28,000 signal conditioner's mute function allows for channels in the system to be essentially turned off while retaining the individual channel settings. The mute function is used when a channel or attached sensor becomes faulty during a test. If the attached sensor or channel began to produce excessive noise, such as when a wiring connection was opening and closing, this could create noise that would propagate through the system to other channels. The problem channel or sensor can be put into a state that turns off power to the circuit by disabling the excitation, disconnects the amplifier from the sensor, and puts the channel into a low gain and low bandwidth state to limit the possibility of noise propagating through to other channels. Once the fault condition has been addressed, unmuting the channel restores all of the previous settings. 28,000 GUI's display panel features a control setup panel for each channel. The setup panel provides access to channel controls for several functions. The wiring configuration settings can be set for a specific channel. This includes a Wheatstone bridge configuration featuring 1-arm, 2-arm, and 4-arm completion options, 2 and 4 wire wiring configurations for constant current circuits, and cable shield termination settings. Setup panel also features shunt calibration modes and sensitivity settings for shunt calibration for bridge conditioner mode. The channel bridge balance and input voltage suppression ranges are set in the control panel. Channel fault limits and fault indicator tolerances are also set in the setup panel. This setup panel provides control and display for these settings per channel and also on a group level. Setup panel controls will be customized for each card model that is in the system. The 28,000 GUI provides control and display capability for the signal conditioning channel's excitation supplies. This is the excitation voltage or current that is supplied to the attached sensor. This allows the level of excitation, balanced constant current, balanced constant voltage, or IEPE current to be set on a group or by channel basis. Depending on card model, the excitation control offers both enumerated excitation values as well as fine adjustment settings. The excitation supply units for the specific card model are displayed in the group panel. The 28,000 GUI allows the amplifier gain to be set on the conditioning channels. The gain can be set in the group control panel across all channels in a group or in the individual channel control ribbons. The precision filter signal conditioners feature a distributed gain topology that has an independent gain stage prior to and after the channel's programmable filter. This distributed gain arrangement allows for the gain to be distributed prior to and after signals are filtered. By allowing some of the gain to be on the band-limited side of the programmable filter, the PFI amplifier allows some of the gain to be applied to the wideband input stage, which has both in-band and out-band energy, and some of the gain to be applied after the signal has been filtered. This allows for the overall amplifier gain to be applied to the in-band signal while preventing the amplifier from saturating on out-band signals that in some cases can be larger than the in-band signal. An example of this is in the in-band signal from an accelerometer and the accelerometer's out-band resonance. The out-band resonance could be much larger than the in-band signal of interest. By using a distributed gain topology, The only part of the amplification that is applied to the in-band signal is the pre and post gain. The out-band signal is only amplified by the pre-filter gain and is removed before additional amplification is applied. The distributed amplifier gain is displayed in the GUI as an overall gain field and a prig and pog field representing pre-filter gain and post-filter gain. This is shown in the GUI by the gain, PRG, and POG fields. The distribution of the amplifier gain between the pre-filter gain and post-filter gain stages is controlled by the user using the reserve field setting. The 28000 GUI offers built-in channel gain calculators that allow the amplifier gain to be calculated in the software to achieve the output sensitivity that is desired for the measurement. To achieve the desired voltage sensitivity at the amplifier output relative to the input stimulus, the amount of amplifier gain must be scaled correctly. An example of the scaling of the amplifier gain would be for a strain gauge circuit. To provide the desired correlation between strain seen at the strain gauge and the output sensitivity in millivolts or volts per microstrain, sensitivity in the amplifier is dictated by the channel gain. The 28000 GUI's Gain Wizard mode calculator allows the parameters that dictate the sensitivity of the circuit, like strain gauge value, strain gauge gauge factor, excitation levels, etc., to be considered and scaled correctly to achieve the desired output sensitivity. In addition, the Gain Wizard mode takes into account full-scale input and full-scale output parameters. All of these factors are linked together in an equation that calculates the required amplifier gain to achieve the desired output sensitivity per measurement unit input. 28000 Gain Wizard mode allows all of these parameters that factor into the measurement sensitivity to be entered and automatically calculated in real time in the GUI software. This built-in feature removes the need for measurements and calculations to be made offline and for them then to be tediously re-entered into the GUI software. The 28000 GUI's Gain Wizard mode allows parameters to be entered and gains to be calculated in real time in the software interface. The Gain Wizard modes are modeled to support specific card models that are in the system. For example, strain cards use units of microstrain, charge cards use units of picocoulombs per G or millivolts per G depending on the accelerometer that's used. The 28000 GUI provides display and control for the signal conditioning channel's programmable filter features. The Programmable Filter's FC field allows the Programmable Filter's corner frequency or 3 dB frequency to be set. This control is scaled for the specific card model that is used in the system and features either fine step programmability of 1 to 2 Hz steps depending on model or fixed frequency settings. The filter frequency units are set in the 28000 group control panel for each card model type. These can be set to units of Hertz or kilohertz. The PFI signal conditioner offers a programmable filter characteristic known as the filter mode. The PFI filter mode settings offer a flat and pulse operating mode. This allows the filter transfer function to be set to perform in the manner of a Butterworth or Bessel type characteristic. These filter characteristics were developed by Precision Filters and allow the transfer function of the filter to be tailored to match the type of analysis being performed. The pulse mode filter, similar to a Bessel response, provides a linear phase characteristic that is useful for time domain measurements. The flat filter mode, which is similar to a Butterworth filter, offers a flat passband and sharp attenuation slope and is useful for frequency domain applications. Each channel offers independent control of the programmable filter's corner frequency and filter characteristic mode. The programmable filters can also be bypassed out of the amplifier circuit. This allows the programmable filter to be removed from the amplifier circuit, allowing the channel to function as a wideband amplifier only. Each channel's filter can be independently controlled to be bypassed or in the circuit, and this is set by the bypass control switch for each channel. For specific card models, the 28000 GUI offers real-time sensor health and excitation monitoring capability. This feature utilizes onboard capabilities on the signal conditioning cards that make real-time measurement of the signal conditioner and sensor operating parameters and report these back to the GUI software. This monitoring capability measures the loop resistance of the sensor and cabling as well as excitation levels delivered to the sensor. This capability allows for the integrity of the sensor, cabling, and excitation supply to be monitored during test. This information is read back and displayed in the 28,000 GUI program, and measured levels of loop resistance and excitation level are displayed in the panel for each channel. In addition, these readings are compared to user set tolerances, and warning indicators are activated if measured readings are outside of these tolerances. This capability allows for the integrity of the measurement circuit to be determined prior to and during measurements without the need for manual measurements. This capability reduces the amount of time required for test setup and can alert the user to problems with the measurement circuit that could invalidate the data while tests are happening. 28,000 signal conditioners offer features that allow for the sensor bias voltages and bridge imbalances to be compensated in the amplifier input. This feature uses a voltage injection at the amplifier input to compensate for bridge imbalances caused by imbalance in the bridge arms or to null sensor biases. This feature can operate in two modes: auto balance mode for bridge type sensors and zero suppress for other types of sensors. The circuit's operational mode can be set in the auto balance or zero suppress setting in the 28,000 GUI. The zero suppress and auto balance routine can be run on a channel by channel basis or in group mode. Pushing the balance or suppress button will initiate the automated routine in the hardware to zero the operating point of the amplifier input. An indicator LED in the GUI display indicates if the routine was successful in nulling the input bias voltage. The balance and zero suppress function also displays the amount of sensor bias that was nulled on the channel input. For zero suppress, this is in units of volts. For bridge type sensors, this is volts per volt of excitation. The 28,000 GUI's auto adjustment control allows automated adjustments to be initiated on the system hardware. The automated adjustment routines can be used to optimize signal conditioner performance by adjusting channel parameters. These parameters include amplifier offset compensation, amplifier gain accuracy, and excitation supply accuracy. These adjustments are used to account for changes that can result in the circuit from ambient temperature changes. The adjustment routines can be initiated from the group or from the channel panels. The adjustments will automatically run in the hardware. An indicator LED in the panel will indicate if the adjustment was successful.